Hello friends, today we are here with the application of De Moivre's theorem. We have to see more applications of the De Moivre's theorem, like we can solve the different equations quadratic equations, cubic equations, and those equations which are not factorizable, right? So those equations which are not factorizable can be solved with the help of De Moivre's theorem and has the solutions which contains the imaginary number like complex numbers, right? So we have to go for such kind of solutions of the equations. So I'm starting with first equation that is given by x cube plus 8 is equals to 0. How we can solve this equation? We can see x cube is equals to minus 8 and x is equals to minus 8 raised to the power 1 upon 3, and it becomes 8 raised to the power 1 upon 3 with minus 1 to the power 1 upon 3, and 8 to the power 1 by 3 becomes 2, and this is cos pi plus iota sine pi, right? By using the polar form of the complex number, we can write minus 1 as cos pi plus iota sine pi. That's it. Because sine pi is 0 and cos pi is minus 1. Therefore, this equation x becomes 2 into cos of pi plus iota sine pi raised to the power 1 by 3. And we can find the cube root of this equation with the help of De Moivre's theorem. So for the De Moivre's theorem, we can write it as 2k pi plus iota sine of 2k pi plus pi raised to the power 1 upon 3. That becomes 2 cos of 2k plus 1 pi dividing by 3 iota sine of 2k plus 1 pi dividing by 3. So here the value of k may be 0, 1 and 2 because this equation contains three different roots because it is a cubic equation, so it contains three different roots. और अगर इसके three different roots हो सकते हैं तो you have to replace k with 0, 1 and 2. Whenever you put the value of k is 0, so we get 2 by 2 cos of pi upon 3 plus iota sine of pi upon 3, and x is equals to 2 into cos of, when you put 1 here, that becomes 3 pi by 3 plus iota sine of 3 pi by 3, and x is equals to 2 into, when you replace 2 here, that becomes 5 pi by 3 iota sine of 5 pi by 3. Now these are the three roots of the given equation, or in short, we can replace these roots by x1 is 2 into cis of pi upon 3, x2 is 2 cis of pi, and x3 is 2 cis of 5 pi by 3 in polar format, right? तो पोलर फॉर्म में हमने इस इक्वेशन का क्या निकाल दिया, सॉल्यूशन निकाल दिया. और अगर आप इसको फर्दर सॉल्व करना चाहते हैं तो सिंपल यू हैव टू पुट द वैल्यू ऑफ cos pi by 3 and sin pi by 3. We know cos pi by 3 is 1 upon 2, that is root 3 upon 2. In this way, we can, this cos pi is minus 1, sin pi is 0, and cos 5 pi by 3 we can find, and sin 5 by 3 with the help of quadrants you can find out their values and substitute to get the exact complex root of the given cubic equation. So in this way, we can solve any equation which contains x cube plus something, right? X cube minus something, x to the power 4 something, प्लस हो रहा है या माइनस हो रहा है. तो इसका मतलब इस टाइप की जो भी इक्वेशंस हमारे पास हो, प्लीज नोट दिस पॉइंट, x रेज टू द पावर k प्लस माइनस p इज इक्वल्स टू 0. इस टाइप की कोई भी इक्वेशंस अगर आपको गिवन है तो यू कैन सॉल्व विद द हेल्प ऑफ De Moivre's theorem, right? So this is the main application of the De Moivre's theorem to solve these simple type of equations. And after that, we are going towards another one. If there are some large equations, right? If there are some large equations, so we can implement that theorem again. So how we can apply that theorem on the large kind of equations which has more than 3 degree, more than 5 degree, and has many terms, like now see here, this is our next equation, x raised to the power 6 plus x to the power 5 plus x to the power 4 plus x cube x square x plus 1 is equal to 0. This is so large equation. How can you find out the root of this kind of equation? In this equation, first of all, you have to observe that each term has positive sign within the two terms. दो terms के बीच में सबके बीच में क्या है, पॉजिटिव साइन है. अगर पॉजिटिव साइन है तो हम क्या करते हैं, मल्टीप्लाइंग सच इक्वेशन विद x माइनस वन. देखते हैं क्या होता है. अगर हम x माइनस वन से इस इक्वेशन को मल्टीप्लाई कर दें तो देखिए क्या होता है. आप इसको जब सॉल्व करेंगे तो सॉल्व करने के बाद x मल्टीप्लाइंग विद दिस वी हैव x रेज़ टू द पावर 7, दिस मल्टीप्लाई विद दिस x टू द पावर 6, 5, 4, 3, 2, 1 only, right? X multiplying with all, right? After that, minus 1 multiplying with all. You have to see x raised to the power this, minus x to the power 5, minus x to the power 4, minus x cube, minus x square, minus x, minus 1 is equal to 0. What are you observing here? Please note it. This cancelled with this and this cancelled with this. All the terms are cancelled with the following terms. Just we obtain x to the power 7 minus 1 is equal to 0. This is our result which we have gained from this equation. And x to the power 7 minus 1 is equals to 0 implies that x to the power 7 is equal to 1, which shows that it is equals to 1 raised to the power 1 by 7, which is same as the previous equation I have already solved. Right? So in that way, you can solve this equation also. X is equals to 1 to the power 1 upon 7. And 1 can written as cos 0 plus iota sine of 0 raised to the power 1 upon 7. We can write it as 2k pi plus 0 plus iota sine of 2k pi plus 0 raised to the power 1 upon 7. Right? In this way, cos of 2k pi by 7 plus iota sine of 2k pi by 7 and k will be 0, 1, 2, 3, 4, 5, 6 because we can calculate the seventh root of unity, right? Seventh root of unity. The seventh root of unity means the values of k are moving from 0 to 6. Whenever you put the value of value of k 0, we obtain x1, that is cos 0 plus iota sine of 0. This will be 1. And x2, cos 0 is 1 and sin 0 is 0, अब वैसे बात है. और अगर आप 1 सब्स्टिट्यूट करेंगे तो we obtain 2 pi upon 7 plus iota sine of 2 pi by 7. And I am using the cis format because again and again we will write cos and sine. It will be very lengthy job. So x to the power 3, x3, sorry, third root, we can obtain cos of, whenever you put 2, that becomes 4 pi by 7, cis of 4 pi by 7. And x4 becomes cis of, that will be 3, that is 6 pi by 7, right? X to the power 5 becomes cis of, you can replace 4 here, that is 8 pi by 7. And x to the power 6 becomes cis of 10 pi by 7, right? And x to the power 7 becomes cis of x to that is 6 put करेंगे इसमें 12 pi by 7. So in this way we obtain the 7 roots of this equation. What was our equation? What was our equation? It has 6 degree, right? So if this equation has 6 degree, so it must have 6 roots only. है ना? The number of roots cannot exceed the degree of the polynomial. Therefore, the roots लास्ट कितने होने चाहिए? 6 रूट्स होने चाहिए. बट यहां पर क्या आ रहा है हमारे पास? देयर आर 7 रूट्स. तो क्या करेंगे आप? इसका मतलब एक रूट फालतू है, एक्स्ट्रा है. उस एक रूट को हमने हटाना है. वो कौन सा रूट है? देखिए आपने x माइनस 1 से इस इक्वेशन को मल्टीप्लाई किया. क्यों? ताकि ये प्रीवियस इक्वेशन में कन्वर्ट हो सके और इसको हम डिमॉरिज थ्योरम की हेल्प से सॉल्व कर सकें. तो इसलिए हमने x माइनस 1 से मल्टीप्लाई किया. अब x माइनस 1 वॉज द एक्स्ट्रा फैक्टर, है ना? वॉज द एक्स्ट्रा फैक्टर जिससे कि हम इस इक्वेशन को सॉल्व कर रहे हैं. इसका मतलब x इज इक्वल टू 1 इज द एक्स्ट्रा रूट. सो वी कैन रिजेक्ट दिस वैल्यू. ओनली द सॉल्यूशंस आर दीज, यानी कि ये जो 6 वैल्यूज आपके पास ऑब्टेन हुई, दीज आर द रूट्स ऑफ द गिवन 6 डिग्री पॉलिनोमियल. तो इन दिस वे वी कैन सॉल्व दैट 6-degree equations, 10-degree equations, which contains all the positive signs within the two terms, successive terms, right? So this is the another solution by using the De Moivre's theorem. And one more equation we can check how you can solve that kind of equation which contains the variable signs between the two terms, right? तो दो terms के बीच में अगर variable signs आ जाए तो फिर क्या करेंगे हम? Suppose this is our equation which contains alternate signs plus minus within the two terms, right? So how can you solve it? But if the equation contains the variable signs like plus minus, in that question you have to multiplying the whole equation with x plus 1. Okay, what will you get? Let us check. This multiplying with this x to the power 5 minus x raised to the power 4 plus x cube minus x square plus x, right? उसके बाद प्लस 1 से जब आप मल्टीप्लाई करेंगे तो x to the power 4 minus x cube plus x square minus x plus 1 is equal to 0. Check whether we can solve it or not. Here we have minus and this is plus, x cube minus x square plus this is x minus x. So all terms again cancelled with each other and we obtain just x raised to the power 5 plus 1 is equal to 0, which implies this is minus 1 and x is equal to minus 1 to the power 1 by 5. Then we can use the De Moivre's theorem, right? So we can say it is cos pi plus eta sin pi raised to the power 1 by 5. So we have to find out the fifth root of minus 1 and we can replace minus 1 with cos pi plus eta sin pi by the polar form of the complex number. Then 1 upon 5 power को solve करने के लिए पहले आप De Moivre's का use करेंगे. We can write it as 2k pi plus pi. Sorry, once again I am writing that is 2k pi plus pi plus eta sine of 2k pi plus pi to the power 1 upon 5, right? That is cos of 2k plus 1 pi upon 5 plus eta sine of 2k plus 1 pi by 5. In this way, we can find out the solution of the given equation by cis form. And you can take it as cis of theta, where theta is 2k plus 1 pi by 5, where k is 0, 1, 2, 3, 4. Because we need 5 roots here and x plus 1 is the extra factor. So we can eliminate it. So x is equal to minus 1. इसको आप छोड़ देंगे. इसके अलावा जो बाकी 4 रूट्स होंगे वो आपको लेने हैं. तो अगर मैं इसमें 0 पुट करता हूं, सपोज वी आर टेकिंग 0, तो वी हैव cis of pi by 5 and x2 is the another root. Cis of, when you put 1, that is 3 pi by 5. x3 is cis of 5 pi by 5 and x4 is cis of 7 pi by 5. x5 is cis of 9 pi by 5 and this is our extra root because this value is minus 1. So we can delete it and we have these 4 roots of the given equation. Because this is 4-degree equation, तो इसके roots भी कितने होंगे? 4 roots होंगे. तो in this way we can implement the De Moivre's theorem very beautifully, make some interesting problems like this and solve with the help of De Moivre's theorem. Obviously, the equation does not has the real roots. It definitely contains the complex roots. ठीक है? तो जहां पर complex roots होंगे वहां पर क्या होगा? De Moivre's theorem होगा. तो in this way we can solve the De Moivre's theorem. आगे बढ़ेंगे और आपको एप्लीकेशंस देंगे De Moivre's के, because De Moivre's theorem is very important theorem to get the solution of different degree polynomials, right? Thank you. Meet you soon in our next video.